Hello and welcome to today's webinar entitled Adding Luxury to Any Home with LVT and Floor Heating. My name is Scott. I am from WarmlyYours. Thank you so much for joining us today. And as we go along, if you have any questions, feel free to ask them at any time by hitting the Ask a Question button there at the bottom of your screen. And we will be glad to go through the presentation with you and answer the questions that come up with that as we go along. So let's take a look at what we're going to be doing in our webinar here in our outline. Excuse me. And we'll be discussing floor heating. We'll do a project example with the flex roll. We'll discuss the installation process. We'll do a project example with the cable, and we'll discuss the installation process for that. So we get the question, why LVT? Well, the reason why LVT is such a popular choice right now is that it's very cost effective. It allows you to get the look of other materials out there in the marketplace without the cost that those other products can lead to. It's very, very durable. It's scuff, stain, and scratch resistant, and it lasts for a long time. Often it can last 20 to 25 years, making it a more sustainable flooring type. And the thing is that you'll probably tire of the look before it fails or before it gets unusable. So it really has a very good lifespan. And the thing is with floor heating, it can add a little bit of extra comfort to your home. So those are a lot of the good things about LVT. It's a very, very popular choice right now simply because of those reasons as we stated above. And what kind of heat should be used with LVT? And we have two specific types of products to heat floors. The thing about LVT is it should be installed over an embedded heating system, such as TempZone. And you'll probably see that in the installation manual, where it will ask you to use the product with embedded heat. As soon as you see the word embedded, you know that you are discussing our product that it seems a bit counterintuitive, but you'll be discussing our product that is to be used with tile. So this tile type installation with the cable and with the flex roll allows you to be very, very flexible with the amount of watts per square foot that you're using to heat the product. If you're on a third floor directly over another heated room, your floor is going to start at 78 or 70 degrees anyway, maybe a little bit warmer. So you don't need a whole bunch of watts per square foot, as opposed to if it's on the ground floor over an unheated crawl space, you're going to want more watts per square foot in an over an unheated space than you are going over a heated space, like a second or third floor room. The LVT cannot be paired with our Environ flooring heating system, the stuff that's silver. So if you see the silver product, it's made for floating applications. You first of all think, oh, my LVT is floating, so I need to use the Environ. Well, you don't want to do that. The Environ is designed for a more resilient product like laminate or engineered wood, and LVT isn't as resilient as that. So let's go ahead and take a look at the cross sections, and we're starting to put the pieces together why you need to disconnect floating from non-floating when it comes to this particular application. Floating with laminate and with engineered wood, and embedded with LVT. Even though they're both floating products, you're going to be learning the reasons why. So let's take a look at the cross section here. As we talked about, different situations require different modes of protection to provide heat. So if you're on the third floor over a wooden subfloor, you don't really have to worry about heat loss below the heating system. But when you're going over concrete, you do have to worry about that. So if you look here at the bottom of the picture, you can see the concrete subfloor. The concrete subfloor, what it's doing, it's going to try to pull any heat down that it can. And that's what happens when you put electric heating wire directly on a concrete slab. It's going to pull the heat down before it ever lets the heat go upwards to where you really want it to go. Now, in the old days, 30, 40, 50 years ago, the only way you'd heat a floor is with hot water. When you're heating a floor with hot water, you're actually heating a gigantic thermal mass, which is a big, thick concrete slab, 3 to 5 to 6 inches thick. Well, we found in the electric business that you can regulate the temperature more accurately. You can make it heat up a little quicker, and you can use less electricity, actually, if you just heat the thin layer above the concrete slab. So we're one of the first companies out there to discover that you're going to get better results by putting the electric heating wire on an insulator. So if we take a look at this cross section, we can see our concrete subfloor. We can see our thin set. The thin set is used to hold the Cerazorb down. We are going to do we're going to attach it firmly to the concrete, and the best and easiest and most inexpensive way to attach Cerazorb to the concrete slab is with modified thin set. So that's what you're going to do. So you're going to put the thin set over the concrete subfloor. You're going to lay the Cerazorb over the top of it. You're going to put it down. You're going to use a roller, and then you're going to lay the heating wire on top of that, because that's going to make the heat go up, not down into the slab where it's not going to do you any good. So once you get that set up, and once you get the heating wires on top of the Cerazorb, then you can attach, or you can cover it with self-leveling cement. The self-leveling cement is a great product. It is a little more expensive than thin set, but what it does is it will give you a completely flat surface that you can put LVT, you can put anything over the top of it. If you want to use carpet squares, if you want to use something else down the road, let's say, yes, we're going to be discussing how to do plywood a little bit later. So thank you for asking. But we are talking about here what you have to look out for concrete, because one of the first jobs we're going to show in our presentation is actually being done in a basement on a concrete slab. So we just want to make sure that everybody's familiar with the layers here to understand why the product was installed the way it's going to be installed. So let's take a look at the wood floor subfloor. And here we can see a product that's called our cable, a temp zone heating cable, but it's the same product. It's temp zone. It's designed for heating tile, excuse me, in most cases. So here we're going to be using fixing strips and cable to string the cable back and forth across the floor. Because we don't have concrete here, because we have a wood subfloor, we have eliminated the layer of thin set and eliminated the layer of Cerazorb, because it's not required when you're going over a wood subfloor on the second or third floor. Now, if this were a wooden subfloor over the top of an unheated space, then yes, you may want to use Cerazorb to give you more insulation to make the temperature go upward. But if you are doing a situation like this where it's a second or third floor and you're doing a wooden subfloor, here are the layers you need. You've got your fixing strips, you've got your temp zone either 3 inches apart or 4 inches apart, and then once you get it all strung out like that on the floor, you will then use masking tape every couple of feet to hold that cable down. Excuse me. So if we, one thing we need to learn here is that the temp zone cable or the temp zone mesh product, when it comes to self-leveling, those products are going to want to float to the top. Self-leveling is very, very dense, and anything that isn't as dense as it will try to float to the top of the surface. So the self-leveling cement being so dense, when you pour it over these cables or these mats, if you don't adhere the mat or the cable very, very well to the subfloor, it'll float to the top, and that is the last thing you want to do. So if we go here, we're going to make sure that our mats are attached very, very well to the Cerazorb with hot glue. And if we go here, we're going to make sure that our cables are attached to the subfloor very, very well with masking tape. So that's going to keep the cables from floating. Then you can put the self-leveling over the top of that. That will give you a flat surface. And then you can lay LVT over the top of it. You can even tile over the top of it. This is what a lot of people do when they're installing tile. They'll just put the cable down They will then cover it with self-leveling. That gives them a heated subfloor that they can attach tile. And the good thing about this is if you do this, you can probably, if you get tired of your tile, you can probably remove the tile and put a new type of tile on there without ever getting down into the heating cable. So what we're showing you here is a way to make a heated subfloor to lay your product on top of. So this gets down to the nitty-gritty on why we strongly, one of the reasons, there's more than one, we strongly suggest that you use self-leveling because we know it's more expensive. We know people like to mix thin set up very, very thin. Well, first of all, you should never mix thin set up very, very thin because that's counterintuitive or whatever that word is. It doesn't comply with the instructions. How about that? We'll keep it in layman's terms here. So if we take a look at this embedding versus a floating floor heating, LVT is much more flexible than other flooring types. It may mold itself to the surface beneath it over the years. So you may not notice that there is a bump in your floor right away, and this bump is just a piece of, is just a box that we've used, and we just let the time lapse here, and you can see what happens to LVT over time. It's called drape, or sometimes you'll see it labeled as a droop, but a lot of times it's called a drape. The drape of the LVT causes it to conform to the surfaces below it. So you may see a little spot in the middle of your floor sticking up 2 or 3 years later. That's simply the LVT bending around it. Well, you don't want to be using a product like Sarah's, like our Environ product, because our Environ product, you can actually feel the ridges of the cable in them. And that's why laminate is used over that, because the laminate won't droop over the wire. But what happens is, theoretically, over the years, if you used our Environ product, you could eventually see the wires going back and across your LVT tiles or your planks, because what it does is it conforms to what's below it. So that's why the LVT installation guides you usually see have a much stricter flatness requirement than laminate, because laminate can bridge little gaps where it's not exactly flat. LVT will eventually droop or drape, and you will see spots where it's uneven over time. Also, another reason why you would never want to use thin set with a trowel, no one can ever get thin set completely flat. I don't care how many years you've been doing it. If you even leave a millimeter difference and you step on a spot that's a little bit lower and you step on the LVT, it'll sound hollow. That's because even being a millimeter off with your thin set and your trowel, any higher areas that are left by the trowel will then create hollow areas on each side of it. So that's another reason why you don't want to use thin set over the heating wire. And it's because of this picture here exactly. What do you want to look for in LVT when you're adding radiant heating to your floor? Try to find an LVT with little or minimal backing. The more backing you have, if it is cork, if it is foam, cork is a natural insulator. Foam is an insulator. The last thing you want to do is create a nice flat heated subfloor, then put a layer of insulation over the top of it, and then your LVT. And that's what happens if you can put really thick a pad between the LVT and the self-leveling. We want to minimize any R value between the heated subfloor and where your foot hits. So you're going to look for an assembled plank with an R value of less than 1. You also, another very important driver is you want to check the warranty of your flooring choice. Is it compatible with radiant floor heat? Yes or no, because the last thing you want to do is install a product that is not manufactured to comply with electric floor heat and put floor heat under it. Also, the next thing you want to ask is, what is the maximum temperature allowed by the manufacturer of the LVT? One thing here that isn't on the presentation is, if they do allow a maximum temperature, ask them if there is a setback temperature maximum, which means if you have ever used one of our products with a thermostat that's programmable, with tile, you can make it be 86 degrees when you're walking on it, and then you can cool it down to 70 when no one's using it, because that'll help you save money. So you're looking going from 85 degrees down to 70, that's 15 degrees different. Sometimes a manufacturer of LVT says you can heat it as long as you don't deviate from the temperature more than 3 degrees either direction. So if you set it for 82, the maximum you want to do a setback to would be, if you go to 82, you'd go to 79. So you can't really do a big setback. So ask if it's allowed to be used with heat, and if it is okay to use with heat, are there any setback maximum temperature deviations that are allowed? So LVT is going to have a temperature limit, and the manufacturers will tell you what that is. So check with them and find out what their requirement is. If they say 82 degrees, well, that's fantastic, because we have an 82 default right here on the thermostat. If they say, well, it's 81, well, you can go here to custom and choose that and set it to 81. And that's how you would set your maximum temperature limit for LVT. So let's take a look at one of our projects that we've done here with a concrete subfloor in a basement in Toronto, Ontario, Canada. So what you do is you start with a SmartPlan, which is a plan that shows how the product is laid out. And if you've never done one of these before, just get a hold of us and we will do this design for you for free with no obligation. If you've never done one of these before, instead of trying to figure out, okay, how far do I roll this out? Do I make any cuts and turns? What do I do? All you need to do is ask us, supply us with a drawing that shows the dimensions of each side, and we will do the installation drawing for you. Just show us where you want the thermostat, because the thermostat location is very important, because that's where the mat is going to start. So if we take a look, you can see a triangle here, and you can see a square over here. The triangle represents the start point, and the square represents the end point. So you always want the start point to be within 10 feet of the thermostat, because you need to run the non-heating lead across the floor, up the wall to the thermostat. You also need to be able to get your thermostat sensor there, and you would run it in a different conduit up the wall to the thermostat. It'll tell you what product fits in there, and also to make sure that your dimensions are correct. So before you go cutting and turning your product, make sure that these dimensions shown on the plan actually match what is in the room. We know in the construction business, room dimensions can change. If room dimensions get bigger, that's not the end of the world. But if they get smaller, it is, because you cannot cut the heating cable or the heating product. You can't buy an 800-foot cable and just string it across the room and then cut it when you're done. You cannot do that. You never, ever cut the heating wire. So we need to make sure that the product we design fits into the space. And that's why the dimensions are so very important when it comes to this product. So let's take a look at the project overview and see what was involved here. We used the temp zone flex roll heating system. As we see, we have 164 square feet. We've heated 129 square feet of it. The most important thing is to warm the area where your feet are. Okay, so there's no way that you're going to be able to heat every square inch of the room. So we try to find the unit that heats wherever you're going to walk, and not heat areas right up against the wall, because first of all, no one ever stands right up against the wall. And if we can eliminate heating those areas, we're going to save money on the heating product that you purchase. It's also going to save money on the operational cost. So if we heat 164 square feet right here, we have a total wattage of 1900 watts, total amperage of 8.1 amps. So that is a 240 volt circuit. If this installation were under 120 square feet, we could use 120 volt. But because it's over 120, we're going to be using 240, because our thermostats can only switch 15 amps. 15 amps at 3-inch spacing, or 15 watts per square foot, equals a limit of about 120 square feet on one control. But if you use 240, you can go up to 240 square feet. So that's the only benefit of 240 over 120 is it allows you to cover twice the space with the same number of amps. So with half the amps in 240. So if this were a 120 volt system, this would be way over. This would be 16 amps. You couldn't control it with one thermostat. So that's why this has been designed in 240. 240 is not more efficient than 120. So down here at the bottom, we see operating costs, and here we can see per day to operate it. So when you get the product, test it. Make sure that it's good before you go to install it. And if you get the product today and your installation is next week, test it today, because if something happened to your product from the warehouse to your step, you want to find out now so you can get a replacement ordered and it's there in time. The last thing you want to do is have a crew coming over. They've got the the self-leveling mixed up. They've got it all mixed, ready to go, and you test it and test bad. Okay, bye everybody. Come back later and we'll put it in when we can get a good product. You always test the product the day you get it to make sure that it is good. You are going to need a digital ohm meter. There's no way to do this installation without a digital ohm meter. The good thing is the digital ohm meter is usually $20 or less at any big box store. And you want to use a meter that is not self-ranging. You want to be able to turn the meter, the knob, right to the 200 range. You don't want it automatically trying to find the range. Get one that's inexpensive with a knob on the front that you can set to 200 and then 20K. The 200 is to test the floor heating. The 20K is to test the floor sensor. So not only are you testing your product 3 times before, during, and after your installation, you're also testing the thermostat sensor. And then when you're actually working over the product, laying it out on the floor or covering it with self-leveling, you want to make sure that you have the circuit check on, because the circuit check is a device that will warn you, or it'll scream at you if you ever do one of two things. If you ever, inside each wire, each heating cable, there's actually 3 wires inside there. 2 wires create a heating circuit, and 1 wire is the ground. The circuit check is always making sure that this circuit is intact, that your heating circuit is going to be working, and it's also testing to make sure that you have no ground or no short between the ground and either one of those heating wires. If any of those conditions cease, like your heating circuit opens up, the circuit check will scream at you and tell you whatever you just did caused a problem. If you have a good reading here, but all of a sudden you created a short by dropping a tool on the wire, it'll also scream at you. So that's why it's so very important to test the system. You're going to need a circuit check, and you are going to need a digital ohm meter. So please keep that in mind. So let's take a look with a temp zone flex roll with LVT on a concrete subfloor. We're building up to it. Let's look at the real life installation. So here with our subfloor preparation, we're going to make sure that we check the LVT to make sure that it's good to be used with heat. If the floor isn't level at this point, we're going to put self-leveling on it first to get it completely flat. Then we're going to install the cable. If this were a really old house and the slab was like this, if you put a cable here and a cable here and your floor is here, your edges are going to be warm, your center is going to be cold because they're too far away from the top of the floor surface. So that's why you need to level it first and then do all the buildup like we showed before. Make sure you clean the subfloor, make sure you get rid of the debris, and please make sure that there's no grease or oil. Those will need to be cleaned. Nothing will stick to it if you don't. So here we're going to be installing the Cerazorb. We dry fit the Cerazorb. We do all of our cuts to make sure it fits. Then once everything fits, we then start using the thin set, modified thin set, to attach it to the slab. Use a weighted roller to get that Cerazorb adhered to the slab, and also lift up on the Cerazorb and look underneath and make sure that you have good adhesion. If you're not, you need to make your thin set a little bit better. Sometimes the thin set has gotten too old, and when you push it down, it doesn't grab. So very, very important to make sure that your thin set is in good condition and not timed out. So here we've laid the flex roll on the floor, and we followed the plan that we saw up here. Remember, here is our plan for this particular space, And here is us laying it out on the floor, just following the instructions. So if you take note, we are going to be putting the cable side down. That's a question we get all the time. The roll is a piece of mesh that's fiberglass, and there's cable attached to one side of it. You can either install it cable side up or you can install it cable side down. We always recommend that you install it cable side down as much as possible, because that way, if you do it cable side up, kind of hard for me to turn my fingers this way, but at the end, the loops are not attached. So if you put it cable side up, your loops are going to try to float to the top. So you're going to have the loop up here and you're going to have the mat down here. That's why it's important to turn it mat side up, cable side down, because that keeps the loops from coming to the top of the pour. So you're going to do your cuts and turns, you're going to lay it out on the plan, and then you attach it to the subfloor using hot glue. Don't lay it out, glue it down, then do the next one and lay it down and glue it. Do not do that, because you want to make sure everything fits first in the room, and then if everything fits with your cuts and turns, then you go back and you glue it down to make sure that everything fits the way it should. You can use a double-sided tape. That's not as good as hot glue. Hot glue is the best thing to use on top of Cerazorb to hold the mats down. Don't forget your floor sensor. The sensor is included in the thermostat box. So you may say, hey, I've got my thermostat. We'll worry about that later. I'll put it in after the system's installed. Don't do that. As soon as you get the product, open the thermostat box up, take the sensor out and give it to the installer, because they are going to need to have that, because you would not believe the number of phone calls we get from people going, I forgot to put the sensor in. We installed my entire floor and we didn't put the sensor in. That's because they forgot to get the thermostat box, open it up, take that sensor out and give it to the installer. Here we can see with this drawing, we can see that the wires are facing downward, cable side down. Here we can see that there's a loop right here. Might be kind of hard to see with my little cursor here. And you can also see that there's wire over here. We're running the sensor into the open loop, and we're only running it about 6 or 7 inches in. You sometimes will see an installation and they run it all the way into the center of the room. You don't want to do that. You want to put the sensor, it only has to go in 7 or 8 inches into the side of the product, but put it somewhere where the sun is not going to hit it. Because if the sun hits the same spot every day, the sensor is going to think the whole floor is that warm. Well, really, where the sun is hitting, it's 85 degrees, and the rest of the floor, it's 65. Keep in mind that the temperature from the sun is actually going to make your floor warmer than the floor heating elements below it ever will, because we're limiting our temperature to 82 or 83, whatever that requirement is, but there is no limit from sunshine. So sunshine can hit the floor can be 120 degrees. So that's something to keep in mind. The LVT, because you're using a temperature in the 80s, is not going to be damaged by the floor heat. That's like taking your hand and putting it on the LVT, and 6 years later you lift it up and something's happened to it. Well, it's not going to happen. You're 98.6, but it's not going to really damage it. And the heat we're supplying is only going to be 82 degrees. So just keep that in mind when it comes to, well, we shouldn't heat this. Well, you really should heat it, because we're just making the surface warm to be at 82 degrees, because we can regulate that temperature within a degree using our thermostats. So make sure you get your thermostat sensor installed. Make sure you run it up the wall to the back of your thermostat, but make sure it can never ever go in the same conduit as the non-heating leads. So never run this wire over a heating lead, never run it along with a non-heating lead. And you can also install a backup sensor if you'd like in the next open loop over here if you want. But the thing is, you can run it up to the back of the thermostat, but do not attach both sensors. Only attach one sensor at a time. So let's take a look at the self-leveling cement. Now, if you're going to be doing one of these installations, it's good to have at least 2 people, and preferably 3, to do your self-leveling installation. Self-leveling is not a job you want to do by yourself, simply because you want to be, while you're pouring the self-leveling over the heating product and working your way from a remote corner over to the doorway to get out, you want to make sure while you're pouring the thin set in your work, not thin set, but you're self-leveling, while you're pouring it and smoothing it out, you want somebody else to take that empty bucket back. You want to trade it with the person who's mixing up the next batch of self-leveling. So he gives that to the guy that carries it, and the guy that carries it brings it to you, and you pour out, and you keep that circle going. One guy is mixing all the time, one guy is carrying back and forth, and the other person is putting it on. You can do it with two people, but I suggest if you're doing self-leveling, do not count on doing this by yourself. Because if you have a big space and you're working one side, eventually these areas are going to have to be mixed together. We don't want one side hard as a rock or firming up and brand new pour over here. You want that all to be liquid in that entire space and work your way towards the door to work out the room. Now, you should use 3/8 of an inch of self-leveling unless the flooring manufacturer says we require a 1/2 inch of self-leveling. Then you use a 1/2 inch instead of 3/8. The secret with floor heating is to make sure that the heating wire is always within 1 to 1.5 inches of the top of the surface. So you have to have a 1/2 inch. So that's going to leave you a little bit of leeway to make sure that you stay within that 1 to 1.5 inches, because that's the depth that the wire best radiates heat. If you put it 3 inches deep, your floor will never get warm. That's why we say we level it first before you do anything. Then you come in and put the Cerasorb in. Then you put the wire in, and so on. Make sure, once again, people don't remember this, when you're putting this product in, adhere it to the subfloor very, very well, or it will float. And when it floats, you'll have wire sticking halfway out of the self-leveling. Then you know what you're going to have to do? You're going to have to pour more self-leveling over the top to give you a flat surface because of all these bumps. Don't ask me how I know. I get these phone calls every day. We're just trying to save you the headache, warning you in advance the things that other people neglect to do that's going to give you a very, very high success rate doing your installation. So now that we have the subfloor poured, we have the self-leveling installed, make sure that it's dried and it complies with the moisture level requirements of the flooring manufacturer. At that point, the flooring can be installed. Do not power up the system until the self-leveling has cured. And the way to know what that cure rate is, it'll tell you on the side of the bag. Do not turn heat on to the self-leveling until it has cured. Not hardened, but cured. And that cure rate is on the side of the bag. Also, we recommend following the acclimation rules that are required by the LVT manufacturer. They'll say, put it in the house for 3 days before you do anything. Put it in the house 6 days before you do anything. Don't turn on the heat within 3 days. Follow all those instructions. Because if you turn the heat on too soon in the self-leveling, can cause it to have problems in the future. Always follow the rules when it comes to cure. Not hardened, but cured. So let's talk about the wiring. We talked about the wiring a little bit a while ago, and here if we take a look at this drawing, you can see that here's our junction box, and here are 2 conduits running to the floor. One of the conduits is for the non-heating lead of the heating product to go up to the back of the thermostat. The other conduit is for the sensor. The sensor and the non-heating leads can never go in the same conduit. First of all, it's usually against code. Second of all, your temperature on your thermostat will never be correct because the low voltage wiring is running right next to the high voltage wiring, and the high voltage wiring will block the signal because of induction. If you have a bunch of rooms, say you're doing a really huge installation and you have 6 mats or 6 cables that you're using, you could actually put a junction box down here, run all your connections to that junction box, then a single wire up to the thermostat. And we have diagrams that show you how to do that. Your local code may require that this step, any of the steps when it comes to wiring, be done by a licensed electrician. We always recommend that a licensed electrician do the wiring for this product. So let's take a look at the LVT floor heating thermostats that we have. LVT is probably going to have a temperature limit determined by the manufacturer. Always check with them. Another question that we get is, oh, I love this brand like Nest, or I love this other brand of these thermostats because I use them to control my HVAC system. HVAC thermostats are not line voltage, they're 24 volt, they're low voltage controls. Our product installed in the floor is either 120 or 240. So a product like a Nest can be used to control your floor heat, especially with tile, because tile has no temperature limits. And the reason why we bring that up is because Nest doesn't have an input for a floor sensor. There's nowhere to put the floor sensor in a Nest. So the Nest never knows the temperature of the floor. Well, you're using a floor that has rules for warranty compliance that say this floor can never get over 82 degrees, or it can never get over 84 degrees. If that's the case, this thermostat that doesn't have a floor sensor input has no idea what the temperature of the floor is. It has no way of regulating the temperature of the floor. It either turns it on or it turns it off. These controls on this page are able to regulate the floor temperature because the sensor is put in the floor and the sensor attaches to the thermostat. So if you've ever called us before and say, yeah, I'm going to be doing laminate, or I'm going to be doing carpet, or I'm going to be doing LVT, can I use this brand of low voltage thermostat? Our first question is going to be, does it have an input for a floor sensor? Because carpeting, laminate, LVT, those products have maximum temperature limits that say you can heat the floor as long as you don't go over this temperature. A thermostat without a floor sensor input cannot be used and keep that floor in that temperature requirement. So use a laminate selection on these, and that'll usually set you at 82. When in doubt, just use that. So that's how you control the floor temperature of the product. Remember, way back at the beginning, we talked about what's the floor temperature limit. Well, we also said ask them if there is a maximum setback temperature. Can it go back 4 degrees? Can it go back 20? Can it go back 1? Can it go back 0? Because if you are not allowed to set the temperature down to a lower temperature when no one's on the floor, that means you have to keep the temperature the same all the time, from the day you turn it on to the day you turn it off, springtime and fall. So in the fall, if you don't have a setback temperature, the people that make that flooring will say you can raise the temperature of your floor, but you can do it 3 degrees per day. So the first day you turn it on, if it's at 65, set it to 68. Then the next day, set it to 71. Then the next day, set it to 74. And at the end, if you go from 82, you go down to 79. Then you go from 79 to 76. And you work your way up, or you work your way down in that maximum increment they give you, 3 degrees, 4 degrees, 5 degrees, whatever that is. So if you can't do a setback, this thermostat right here is the perfect thermostat for you, the Entrust, because you just set it and forget it. You set it to 82 and it stays there until you change it. So you ramp up in the fall, you ramp down in the spring, and this Entrust will keep it exactly that temperature for the entire winter, 24 hours a day. If they do allow you to set it back, then use the Wi-Fi or the touch, because they will let you set it to 82, and then at night when no one's on it, set it down to whatever temperature is allowed. That's what we mean by setback temperature. That's a very important question to ask. So let's take a look at the finished product. The finished product looks like we have a beautiful floor, and it works like $1,000,000 because it's so nice and flat. You walk across it, you don't hear any of that hollow steps that are caused by using thin set instead of self-leveling. You have a nice flat floor that feels solid underneath, that doesn't sound hollow. So let's say that 5 years down the road, we decide, you know what, I hate this color. I'm going to change the walls to orange, and I want to get a different color. That's fine. All you do is you lift up the LVT, you take it to recycling, and you put in LVT that looks better with orange walls, and all of a sudden you now have a brand new room decor, and you have not even touched the heated subfloor. You just pull the old floor up, put the new flooring type down, and you are set. So let's take a look at this installation. The project cost for this temp zone roll was $22.67. And that includes the temperature, the temp zone flex roll. That also is the Inspire Touch thermostat. It includes the circuit check and the Cerazorb. Now you're going, oh, I'm going to look at the Cerazorb price. This looks pretty expensive. Well, Cerazorb, once again, is going to allow you to go from a floor that doesn't feel cold to a floor that feels warm. If you're spending $1,100 on a heating mat, do you want the floor to not feel cold because it's only able to get up to 74 degrees? Or do you want it to feel warm because it can get up to 82 or even higher? That is your decision, and that's where Cerazorb comes in, because if you put the heating wire directly on the concrete, it's going to make the floor feel not cold. Seems like kind of a downer. I spent all this time and money, my floor gets to 74 degrees. Okay, well, it doesn't feel cold, but it doesn't feel warm. If you want it to feel warm, you're going to want the Cerazorb, because that is going to allow the heat to go up into the room as opposed to down into the concrete slab. So let's take a quick look at the Tempstone cable with a wood subfloor. It's on a bedroom on a second floor, and it's in Illinois. So once again, we're not showing you Florida installations. We're showing you real world cold, because I live close to Kildare. I know it gets really cold in the wintertime. So these are real world examples that we're showing you here. First of all, we started with a sketch. And this is, you can see, just a hand-drawn sketch on a piece of paper. But what's so important is the dimensions are shown here. We are showing what's on this floor. Okay, we have dressers here. We have a bed. We have a closet. Now, the National Electric Code frowns upon heating inside of a closet, so we didn't heat that area. First of all, no one stands inside of a closet. There's no reason to heat a closet, and it's against code to heat a closet, so you might as well not do it. But what we are doing is we're heating under a bed, and when you heat under a bed, you need to make sure that the bed is not a boxed bottom bed, because anything that has a solid bottom that sits directly on the floor is going to trap the heat. Trapping heat causes the heat causes overheating. You can cause your floor to fail if you trap heat and cause it to overheat over years and years and years. So this is installed under the bed, but the bed is up on a pedestal. Not a pedestal, but up on a bed frame. And another thing to watch out for is the dust ruffle around the edges. You want to make sure the dust ruffle has about an inch clearance to let the heat out, because that'll allow you to move the bed to other locations, because you don't want to just not heat here, because let's say 3 years later we decide to put the bed over here. Now you have a bed that's over the heat and a bed and a spot over here that's cold because they never installed the heat. So when you're installing floor heating, buy a bed that is on a bed frame that's up off the floor, and you are going to be wanting to purchase dressers or chests that are up off the floor that let the heat out. If these were boxed bottom dressers, we wouldn't heat under them either. But that's just one of the things you have to realize when you're doing floor heating, is there are certain things I need to look out for. I need to make sure I don't trap any heat. So here is where our room setup is noted. And here's our SmartPlan for the cable, because we're going under those chests, we're going under those dressers, we're going under the bed. But the thing is, the bed is up on a bed stand, and or on a mattress stand, or whatever I can't think of the word right now. And these are up on legs. So you have a closet here that we're not, and there's our thermostat location. So there's our triangle, there's our square, and our cold lead is going to run from here to the thermostat. So we start and we just go back and forth, back and forth, back and forth. So let's take a look at Tempstone cable for LVT with the wood subfloor. So here is our wood subfloor. Make sure to check the luxury vinyl flooring for which the subfloor is designed for. Make sure that you can heat it. Primer should be used before you put anything on top. So one thing we didn't mention before when we were talking about the Cerazorb and then putting the heating on top of the Cerazorb on concrete, when you put the Cerazorb down, that's when you're going to want to cover it with the primer if there is primer required by the self-leveling. The self-leveling bag will say requires such and such primer. If they require it, and they'll tell you the brand, they'll tell you the type. Always use that so you get your warranty when it comes to that. So this floor, as you can see, it's kind of shiny. Normally, plywood or OSB isn't that shiny, but the reason why it's kind of shiny is because that's the primer for the self-leveling. You do that, and believe me, the first thing you want to do is you want to make sure that you plug any holes around the perimeter or any holes where you've pulled up a nail and it now goes down into the kitchen below, because you will have a pile of self-leveling in the kitchen below there if you don't plug those holes. So we had to use some caulk in some areas here, and we had to caulk the seams a couple places, not everywhere. We didn't even use a whole tube, but we filled any holes and we filled any cracks. And you can see, if you look really carefully, you'll see that there's a bead of caulk around the edge. That keeps the self-leveling from going down the walls. So remember, the product's going to try to float to the top, so make sure that you adhere it very well to the subfloor. And here you can see now that the primer has dried. Now we've laid our cables out and our cable strips, and we've laid it out on the floor. We are going to make sure that you keep that evenly spaced. This particular job is 3 inches. On the second or third floor in a warmer climate, you may actually be able to do 4-inch spacing instead of 3. That'll save you energy costs, and it'll also save you installation costs because you're buying less. So if you're in a warm area on the second or third floor, investigate 4-inch spacing instead of 3. So you can use glue, you can use screws, you can use nails to hold the strips down, and then you just roll the cable back and forth inside the strips. If you take a look at the installation plan, we're going to go back here. The installation plan has a red dot. That red dot is the halfway mark. So if you're laying this product out and you're going, and all of a sudden the red dot is over here, that means you're using too much. You're going to run out. If your red dot is over here, that's the halfway point of the cable. You should be halfway done here. If you're halfway done over here, your spacing is too wide. You need to go back and make it narrower to comply with your electric code and also to fit into that space. That's why we put the white piece of tape halfway on the cable so it matches up with the halfway mark shown on the plan. So if we take a look here, we can see here on this photo, I love this photo because you can see the cables and you can also see the tape going across the cables every 1.5 to 2. And if you look over here, you can see the self-leveling. You don't see the cable coming to the top. You do a little bit here because we haven't done that second bucket yet. So if you look over here, you can see that's completely flat. And here we can see laying the LVT on top after the floor has cured or after the moisture content has dropped below the level. And then we installed our thermostat because we put our thermostat sensor in the floor when we were doing our installation. And it looks fantastic. That is a great looking floor. You can't tell it's LVT. It gives you a nice firm feeling underfoot. It also has the sensor built into it, so we know that we're not overheating it. The sensor, if you were curious, the sensor is over on this wall, not here where the sun hits. Remember, you never want to put the sensor where the sun is going to hit it, because the floor there could be 90 degrees and the rest of the floor and the rest of the building could be 60. So always put the sensor on the wall away from the sunshine. So now is a perfect time to ask any questions that you might have. And we do happen to have some questions that I had a while ago and I lost them. And I will, oh, here we go. And if we take a look here, question, outside uses, 4-season rooms from Winston. Winston, this is a great question. We get this question all of the time. And let me see if I can expand this and you can see it a little bit better. I'm going to go for it. I'm going to go here. Yay, we can see it. So outside uses, 4-seasons room. First of all, when you're asking yourself, is it a 4-season room? Is it a 3-season room? Is it inside or is it outside? Our products, certain products can be used indoors, but they're not allowed to be used outdoors. Certain products that we make for outdoors cannot be used indoors. How do you know indoors from outdoors? If anytime during the season rain or snow can hit the floor, that's considered in most cases an outdoor space. Because if you're indoors, rain or snow should never hit your floor if you're indoors. So if your floor is going to get hit by rain or snow, that's an outdoor application, and that's probably what your your inspector is going to be looking for. Is this indoors or outdoors? Remember, the product always has to be installed per the National Electric Code. Local code always has a higher, it always overrules the national. Local code is what is gone by. National code is just the guideline that we designed to because it applies to most jurisdictions. So temp zone, that the product we've been talking about all along, cannot be used outdoors. If this floor is going to be getting hit by water, snow, rain, anything like that, temp zone is not listed for outdoors. You have to use our snow melting product, which is listed for outdoors. So that's one thing you have to keep in mind. Snow melting has a whole different application of how it needs to be installed, thicknesses. So that's one thing that you want to keep in mind. You may be able to use slab heating cable, which can be installed outdoors. So keep that in mind. But the temp zone product we've been talking about cannot go outdoors. What are the limitations of the heat under the LVT? Thank you, Bob, for asking that question. The LVT manufacturers will state the maximum temperature for underfloor heating and whether their product can be used with electrical floor heat or not. That's not up to us. It's up to the manufacturer of your flooring, which leads us into the next question supplied by Mark J. If LVT is approved to be heated, are there any known long-term effects of LVT from heating mats? Well, if the manufacturer says it can be used for heating, then they've done those studies. We can't study 600 different types of floor and give you an exhaustive list. We go by what the manufacturer has tested. They're responsible for testing their own product to see if it will work in the different applications people are looking for. LVT manufacturers are going to tell you yay or nay because they've done long-term testing to find out will it last the warranty period. And yes, if it lasts the warranty period and you install it the way the warranty states, then you shouldn't have any problems at all. Keep in mind, we talked about this a little bit earlier, sunshine coming through the windows is going to make the LVT hotter than the floor heating cables ever will, because the floor heating cables are going to be limited to 82 or 83, whatever that is. There is no limit from the sunshine hitting through the windows. So you may notice in your installation manual that it says, please keep the drapes drawn, or please try to limit the amount of sunshine hitting the floor, because the LVT manufacturers know that not only will that possibly bleach out the color, it can also affect the temperature that LVT is subjected to. Keep in mind, we're heating to 82 degrees. That's less than putting your hand on the floor. So that heating is not going to be damaging the floor. It's the heat from the sunshine hitting it. It could raise it to 100 or 150. Not 150, but you get the point. That's why the primary selling point of electrical floor heat over hot water is hot water has a thermostat that sits on the wall and it gauges the air temperature in the room, has no idea what the floor temperature is. But with electric floor heating, we know exactly what the temperature is, and we can keep it within 1 degree all the time if we have to. Hot water can never do that, because when you turn on the boiler, it gets real hot at the beginning. Then after it cools off, it cools down. We call that overshooting and undershooting. So it's really doing this. As it kicks, as electric, it's the same temperature all the time. So those are some fantastic questions that we got from those three folks. So thank you so much for asking those questions. And it doesn't look like we have any questions from Facebook. So unless you can think of anything else, let's talk about our next webinar. Join us next time, Thursday, June 10th, for Finding and Installing the Perfect Towel Warmer. That's Thursday at 1 p.m. Central Time, June 10th. You can also join us daily. We do daily trainings here at Warmly Yours on the same platform, on Crowdcast and on Facebook. So make sure you join us Mondays at 4, Tuesdays, Wednesdays, Thursdays, and Fridays, all the times there on our website. Let's talk about our monthly promotion. For May of this year, 2021, you can save 20% on Environ Easy Mats. These are the large mats that come in various sizes that are like blankets. You lay the blanket out on the floor, you put your flooring over the top, but not LVT. You can use it with laminate, you can use it with carpet, you can use it with engineered floating wood. That's the type of product that you can use with that. 20% off Environ Easy Mats. We value your feedback, so you're going to receive an email very shortly asking about your experience during this webinar, and we appreciate your comments and suggestions. If you didn't like me, let me know. Then that way they won't have me do the next one because there's no reason to subject our watchers if they don't like me giving the presentation. Also, if there's information that you'd like to get, please let us know, because we'd love to talk about the stuff that you're interested in, not just us picking some content and going, well, they might like this, let's try it. Let us know what you're interested in hearing about, and we will be glad to provide that to you. Feel free to contact us anytime we're here. Our toll-free number is 800-875-5285. You can email us anytime, and we will get back to you ASAP. And also check us out on our website at WarmlyYours.com. Or if you're watching us on Facebook right now, you already know our Facebook address. So thank you for joining us there. And we really, really appreciate you taking the time to visit with us today. So until next time, stay warm and be radiant. Bye, everybody.